to learn this, the best way to do this is to do as many of these problems as possible. Okay, so I'm going to go through two of these u substitution antiderivative integrals. In this case, I'm just asked for an antiderivative, but in this one here, I'm actually looking for a definite integral. So I would just need to find an antiderivative of this integrand and then plug in the upper bound minus the lower bound. But we'll get to that. Let's start with number 5 first, going backward order. So here, okay, now you see it's tricky because you really want to see what you can make u, so when you differentiate, something kind of cancels out or is equal to that. And in this case, right, it's kind of a giveaway for me when I see the higher power. The higher power one is going to want to be u, because when you differentiate, you need to get, you're going to go down a power, right, when you differentiate the polynomial. So I might get the x squared value. So I'm going to take this whole thing as u, and I'm going to see what that gets me. It might not be the correct guess the first time, but I'll try that to start. So I'll say u equals this 3x cubed plus 6x squared plus 3x plus 5. And now what I do is I differentiate with respect to u du is, I'm sorry, I differentiate with respect to x, and I'm going to get 9, 3 times 3 is 9, x squared plus 12x plus 3. And then the derivative of 5 is, of course, 0, and this is dx. Okay, now if you look, right, I can factor out a 3 from each one of these terms, and when I do that, it becomes clear that I did this the right way, because this becomes 3x squared plus 4x plus 1 dx. And now I know that I've done this correct because this inside is exactly this top part here, this numerator. And now you just want to be careful with how you substitute. Now me, again, I like to just solve for dx. I write it dx is equal to 1 over 3 3x squared plus 4x plus 1 and du, right, like that. I mean, times du, whatever this here is dx. You should see that when I divide on both sides by this, right? When I divide on both sides, I get just dx, which I put over here. And now I'm gonna go ahead and substitute things in. I'm gonna put u in, and I'm gonna put the dx in to this antiderivative. So let's see, I got antiderivative, and I'll just rewrite this whole numerator just to illustrate how we handle that. So it's 3x squared plus 4x plus 1 over, now I do want to substitute this as u, right? This whole bottom part is u, this is what I call u, this whole bottom part, so I'm calling it u. And then dx I solved for as times 1 du over this 3 times 3x squared plus 4x plus 1. Right? And now it sort of becomes clear that this cancels with this. And then you get the integral. The 1 over 3 I can take out. Don't forget, it's just a constant. It's just a constant that's being multiplied. This is 1 on the top now, and then there's the 3 on the bottom from here. So that comes out, and it's 1 over u du. And now I just need to know what the antiderivative of 1 over u is, which we should know is ln, absolute value of u, plus c, some constant c. And now I've taken the antiderivative. I've done this part. I've taken the antiderivative of 1 over u. I got ln u. I multiply by a third. And then this, I go back for what u is after I've taken the antiderivative. So it's ln u. Instead of writing u, I write 3x cubed plus 6x squared plus 3x plus 5, all that absolute value, plus c. And my choice then is choice C. Is that correct? Yeah. This is the ln absolute value, 3x squared plus 3x plus 5, yeah, plus c. And it's 1/3 in the front. So for this one, I get c. Now again, doing this and seeing how you get this answer and going through this, it required you to know the integral of 1 over u, the integral of 1 over x dx, the integral of 1 over t dt, whatever variable you want, the integral of 1 over u du, right? The antiderivative is ln absolute value of x plus c, ln absolute value of t plus c, right? Again, just changing the variables, just trying to illustrate that it doesn't matter, ln absolute value of u plus c. Okay, anti-differentiation of 1 over x, 1 over t, 1 over u, whatever. Same idea. Okay, now, next one. Okay, again, I see I have this integral here, and I realize that what I want to do here is that I actually want to take that u be the higher power one. I want to say u is this x to the fourth, because if I want it to be equal to this, if I want the derivative to be equal to this part, right, I know the power is going to go down by 1. So if I took this to be in u, if I said u is x cubed plus x, right, I would know that I would differentiate and get an x squared. But then what would happen with this x to the fourth? It would never cancel. So I kind of know to take u to being the higher power one, the 2x squared plus 9. And then again, du is just going to be the 4x cubed plus 4x dx. And again, if I solve it for dx, or if I factor out a 4, let's just see how I factor out that 4. We're going to get 4x cubed plus x dx. And now I got something that's matching. This x cubed plus x is right here. And that's a good thing, because then when I solve for dx, I get 1 over 4x cubed plus x du. And now I substitute everything in. So I get my integral, my definite integral in this case, right? So my definite integral from 0 to 1. And again, I like to leave the x cubed plus x, and then I substitute for what I know. This whole thing becomes just u to the 1/2. And then dx, right? Instead of writing dx, I write 1 over 4x cubed plus x du. And then x cubed plus x cancels with x cubed plus x. This is 1/4. 0 to 1, u to the 1/2 du. And now I just need to know how to find the antiderivative of this right here. And this is just 1/4. And it's u. I add 1 and divide by that same value. 3 over 2, right? Because the half plus 1 is 3 over 2. And I'm dividing by 3 over 2, becomes 2 over 3 that I'm multiplying by, plus c. This 2 cancels with this 4, is just being a 2 on the bottom, so it's 1/6. And then instead of writing u, I write x to the 4th plus 2x squared plus 9 plus but the c in this case, okay, so good, I'm glad. The c, it won't matter, because I found an antiderivative, but remember now, I need to go and I need to plug it in from 0 to 1, right? I want to plug in, I forgot that plugging in part, right? So it's, technically I shouldn't put it from the same bounds. Once you change to u, you could use this here to change these bounds, but I'll go back for x and not change the bounds. So there's a way to do it differently, that's all I'm saying. There's a way to do it differently, but let's just go back for x. So let's go back for x. You don't need c because the c is going to subtract anyway when you plug it in into here. You'll minus out the c if you did put in the c. So you don't need the c in this case. So I plug in 1. I'm going to get 1 plus 2 plus 9 is 3 plus 9 is 12 minus the 0. I'm going to get 9. And I got to remember to do 1/6 of the whole thing. The 1/6 times 1/6. So that's 3 times 1/6. It's 1/2. So I did something wrong. Let's take our time. Let's go through it again. Let's see. Oh, because what did I forget? To the 3/2. There we go. Right? Because I plug in back for u. It's not just u. It's to the 3/2. So I plug in 1. I'm going to get 12 to the 3/2. Minus 9 to the 3/2. So, and then times 1/6. So what's 12 to the 3/2? Oh boy, I'm not too sure, but I can maybe simplify this. So it's gonna be the square root of 12 times 12, right? Because this is 12 to the 1/2 times 12 to the 1 is 12 to the 3/2. Now 12, that's gonna be the square root of 4 times the square root of 3. And the square root of 4 is 2, so this is 24. Square root 3 minus, now the square root of 9 is going to be 3 to the 3rd is 27. And now it's all times 1/6. So I'm going to get 24 by 6 is 6, 12, 18, 24. 4 by square root 3 minus 27 by 6. They're both divisible by 3, right? So 27 by 3 is 9 over 3. This is 3. Oh, wait. So what did we do wrong here? 27 by 3. Oh, by 2. Good. 9 by 2. Okay. And let's see. Is that one of our choices? 9 by 2. 4 over 4 square root 3 minus 9 by 2 is choice C. Take your time with these for sure, right? The multiple choice helped me out here because I was like, okay, wait, what did I do? I forgot the 3/2. I forgot also that it's a definite integral, right? Which means that I just need to find an antiderivative of this whole thing. Plug in 1 minus the 0. I found an antiderivative as this right here. I plugged in 1. I got 12 to the 3/2 minus, when I plug in 0, I get 9 to the 3/2, right? So make sure that that's clear, right? I plugged in 1 for x here minus 0 for x here. And then I multiplied the whole result by 1/6, and I got this right here. Again, take your time with both of these. Be sure you practice this over and over.